to another episode of 3-minute videos with Nathaniel. It's now the 104th video. Sorry, I am not doing it, counting it right, but I remember it's the 104th video, and 104 is a multiple of 8, which is the last coefficient in here. In fact, it's 8 times 13. Okay, today we'll now be doing question 1J of 2009. We need to find how many positive integer solutions, which means that we need to find the whole numbers greater than 0. Now, let's calculate this. Now, look what you need to solve a strange cubic equation in both x and y, which is what we might not want to do, but as mathematicians, we look out for patterns. If you see here, if you know enough about factorization, this factorization is equal to x plus 2y cubed is 2 to the power of 30. And since for cube roots you only have positive roots, x plus 2y equals to 2 to the power of 30 over 3 equals to 2 to the power of 10. If you know your powers of 2, this is 1024, but we will expand it here. Because the answers are given in special forms of powers of 2. Now let's calculate this. So 2y equals to 2 to the power of 10 minus x. Y equals to 2 to the power of 10 divided by 2 is 2 to the power of 9 minus x over 2. See, it's a line. The solution is a line. Now, how many positive integer solutions are there? So we count 1 for every single value of y, because not every single value of x will result in an integer solution. So we have 2 to the power of 9 plus 1, since we have what's called the fence post error, and then we subtract 1 for the 0 when x, and subtract 1 for the y is 0 case, and then we're left with 2 to the power of 9 minus 1 cases. Or, if you know your powers of 2, 511. Another interesting fact about this polynomial, so when you take the special case x plus 2 to the power of 3, you will have x cubed plus 6x squared plus 12x plus 8. Now look, the power of x, the exponent of x, tells us how many dimensions we have in each component. So this polynomial is actually a polynomial that describes a parallelepiped or a rhombus prism or a cube or a cuboid or whatever 6-sided hexahedron you prefer, even the triangular trapezohedron. Now, you see, this has power 0, so we write it here. So that means this hexahedron has 8 vertices. 8 vertices. And since this x has index 1, we can say that this is 12 edges, 6 faces, and 1 cube, or whatever solid you prefer. Now, let's try x plus 2 squared. Let's see if this is true in squares. X to the power of 2 plus 4x plus 4. As it turns out, this suspicion is actually true. You can try x plus 1 squared to get something like triangles, triangles, tetrahedra, pentatopes, hexatopes, or whatever you prefer. But this, x plus 2, gives you all the square-based hedrons in front of your face. Now, if you try 2x plus 1 cubed, you will have the same what's called dual polyhedron, which is the octahedron. Now, here's an interesting fact about 8. This is something that you might not expect because I do a lot of videos about mathematics, but here's a strawberry. And what has strawberries got to do with the number 8? Well, strawberries are octoploid, meaning that they have 8 copies of the genome in every cell. That's why you see them in DNA experiments all the time. You see little strawberry, each cell has 8 copies of the genome. So I'm sure the cell must be really packed. Anyway, thank you. And I just gave you a fact to savor. So next time you're eating a strawberry, think of how many copies of the strawberry's genome you're eating. Goodbye.